Good day everyone. Welcome to the second lecture of the course Biological Data Analysis and Visualization with R. In this class we will be setting up R. So, I will show you how you can set up R, and then we will be talking about basic operations in R. So, this is something that will set the base. Okay, so as I mentioned, these are the two parts that we will be covering. So, first we will be setting up R, and I will show you hands on how we actually can set up R in your system, and then we will be also looking at some of the basic operators, and again I will show you hands on in this system how we actually use these operators. So, we will take very simple examples when I illustrate the basic operations, but you can imagine, probably you will probably understand later on how we can actually use these operators in very complex operations. Okay, so first up is the setting up R. So, we will be doing the R installation, right, and I will just show you how R is you can install R. I will also then talk about how you can install packages and where you will find this list of packages, and then how you can use functions from packages, right. So, I will give you a very brief overview how you can use functions from packages, which will expand upon later on when you discuss specific packages, right. So, where we will take examples, right, where we will have example data sets where we will apply specific functions. So, we will get to learn this in much more detail in the later classes. So, some of the basic operators or basic operations in R. So, how do you actually find out working directory or set working directory, right? This is something that's the first step when you start your analysis. We will talk about assignment operators, how we assign values to certain variables. The arithmetic operators, right, how do you carry out arithmetic functions, right, simple mathematical functions. You also have relational operators, right, how do you actually check whether some number is greater than something, etc. So those who are familiar with other programming languages, they might find some similarity, but it's good to discuss the actual notations, actual signs that we use. So, for the working directory part, we have these two functions that we will use, get WD and set WD. I will show you, I will illustrate you in a moment how we can use these functions in R. We will use also these functions ls and rm, and I'll then when I illustrate in R, I will tell you what these functions do. You will understand it better when I illustrate. We then move on to the assignment operators, right. So, how do you assign values in R? So, there are two operators that we will use. One is of course the equal sign that is used in other programming languages as well, and then we have this arrow sign which we also use for assignment. Now, in R we also have the arithmetic operators, right. So, we have the normal one, the standard one, which is common across other languages, right, plus, minus, star and slash. So, this is addition, subtraction, multiplication, division. On top of that you have the power, right. So, you have the power function, right. So, if you, let's say you want to do 2 to the power 5, so you have this power function. Then you have the second one is the modulus function, right. So, this one is the modulus function. So, for example, if you divide 5 by 2, you want the remainder, so that remainder would be 1, right. So, this modulus function will give you 1. Then you have this function, this is slightly different from the previous one, and here you see, right, there is just a extra slash in between, right, between these two percentage signs, and this is integer division. So, if you do 5 by 2, it will give you 2, right. So, you have modulus function, you have integer division function. We will take some examples, right. So, you will understand this better, and you can of course try it out yourself once we have completed this part. Then we have mathematical functions, right. So, we can do, for example, take log, we can take exponential, we can also get max, mean, right. If you have set of values, you want to get the maximum value, you can just use the max function. You want the minimum value from a set of values, you get minimum function. You have median function, variance is the interquartile range. So all these statistical measures you can actually extract from data using these functions. So we'll apply these functions a bit later, right, when we talk about data structures, and we define data structures. We have matrices, we want certain measures like max, mean, median, variance, etc. We'll apply these functions. So we'll demonstrate those when we take more data sets, right? So we work on actual data sets. You also have sum function. So if you have a set of values, you just want to take the sum, then we'll apply this sum function. The round function, it actually will round numbers to certain decimal points, right? So you can say only up to 2 decimal points, right? So that is something you can do with the round function. Then we have some of the relational operators, right? So you have this equal sign, and then you have not equal sign, you have less than sign, you have less than equal to sign, greater than sign, and greater than equal to sign, right? So some of these signs you might have seen in other programming languages. If you are familiar with those programming languages, you have seen them. We'll actually apply them a bit later, right, when we try to when you work with bigger data sets, right? So or maybe we can try very simple things and see whether what is the outcome of these comparisons. Okay, so with this brief discussion, I'll now go into the hands-on part, right, where we'll discuss how to install R first. Then we'll talk about the packages part, where you find these packages and how to install packages in R, and then how to use these packages, right? Following that, right, following that very brief discussion, we'll talk about these basic operations. I'll show you these basic operations in R, right? This get WD, set WD, etc. Step by step, we'll cover all these functions that are there. Okay, so let's move to the hands-on part, right? So I'll go into R. So you can install R from this cron R project, right? So here you have the database, right? So where you will have these packages. So R works on Linux, Mac, and Windows. So any system you have, you can install R. You just need to click on the right version and you can install it very easily. So here is, for example, if you want to install for Windows, right? So I just click on this download R for Windows, and it will go into this, right? And you can install this base version, right? And you can install for yourself. Okay, so install R for the first time, and this is how it will work. Here is the download R 4.4.1, right? This is the latest version. Of course, this is regularly upgraded. So if it is upgraded, you can upgrade, and because the packages are also upgraded, so sometimes the old packages might not work with in the new version, right? So you also need to upgrade packages. Okay, so if once you have installed this, so I have installed this in my system, you can also install something called R Studio. Okay, so I'll just show you, right, how. So again, this is something that you can also install in this system. Here is the R Studio, right? So you can install, right, R, then install R Studio, right? And this is kind of like an environment which will give you a comprehensive overview of what are the packages that you are using, and what are the packages, what are the environmental variables that are there, etc., etc. Right? So this is something you can also do. So I have already installed R here. This is the latest version that I have. So I can start it here. You can see the version of R from here. So here you will see, you can go to this help button. Okay, so what I'll do first, I'll increase the size. So you can see the help button, and then about function, it will tell you which version you are running. And here also you can see the R version, right? So we can, this is the, when you start, this is what you will see. and using Control plus L you can remove this part, so that you can now type your commands here. Okay, so we are running in Windows and it's very straightforward. If you want to quit, the command is Q. Okay, so this is the command that's you have to use, and it will ask whether you want to save or not, and based on that you can quit. Okay, if you are running Linux, okay, so this is something that you can also run in Linux. You can run in command line. Okay, so R will run in command line. For doing that, you have to use this R command, just R command in your terminal, and it should load. Okay, yeah, so this is you load the R command, and here again you have this, you can use Control L, and then this will be gone, and here you can again type your commands, whatever commands you want to write. Okay, so let's we'll keep this discussion limited to the Windows version for now, because probably most of you are running Windows version. Okay, so once we have installed R, now I'll go into the packages part, right? I'll show you how you can install packages and where you will find these packages. So for R, so here are the different packages that we'll find. So let's go to our home page again, and here are certain, okay, yeah, so to run, right, and here are certain mirrors that we'll see. Okay, so these are the places from which you can download packages. Okay, so we don't have to worry about these the links from which you should be downloading, right? We can download from anywhere. There is an way to download this from R itself. Okay, so the other part that I wanted to mention, okay, so here you have the bioconductor, okay, and this is where we have a lot of these very useful packages, right? So this is built in R, right, and with the packages that are focused on bioinformatics, right? So to see the packages, you can go into the packages function here, right, and you get a list of these packages. Okay, so we can take any of these packages and we can demonstrate, right, how we can install packages. Okay, the other one we have is separate package list for R itself. Okay, so these are not bioconductor packages, these are R packages. Okay, so let's see where we can find those packages. Here. Okay, so what I'll do is I'll simply search R packages here. So you have the available current packages by name. Okay, and you can see there are hundreds of packages in here. Okay, and these are the list of these packages, right? So again, they are alphabetically sorted. So these are the packages that are for start with A. The package names are on the left, and there is some sort of brief description of what these packages do. Okay, so this is something that's useful if you want to, let's say, use certain packages for certain purpose, right? So you have certain purpose, you can search for this. Okay, for example, we can ask, let's say, one of the packages we can ask for is, let's say, ggplot2. Okay, so this will not be here, right? We have to search, and you can go into, right, because this is alphabetically sorted, there are hundreds of packages. You can actually find where ggplot2 is. So it will find where ggplot2 term appears, right? This is a package that we can install. So I'll show you how you can install these packages in a moment. So let's see if we can find ggplot2. Okay, maybe we can sort based on alphabetical order, right? And let's see if we can see ggplot. So you can see the list of packages, right? So it's a huge number. Okay, so finally we are in the GG part, right? And let's see where we find the ggplot2. Okay, so here we have the ggplot2 package. Okay, so again you have a lot of ggplot associated packages. Some of them we'll be discussing later on. So here's the ggplot2 package, and then we can install this package and look into the manual, right? How to use functions from this package. Okay, so you don't have to install this manually, download the installer, etc. What you can do is very simple in R is here you can simply say install dot packages ggplot2. Okay, so the package name should be within double quotes, right? So install dot packages, and it will ask for any CRAN mirror, like the sites that I showed you. You can choose any one. I have chosen the first one, whatever was there, and it will install this package. So what it's doing, it will also install packages that are required for functioning of this ggplot2 package. We'll use this ggplot2 package for visualization later on. It's a package for data visualization, for making plots. So we'll use this package for data visualization in later classes. Okay, so once we have installed this, we want to use certain functions, right? So how do you find these functions here, right? How do you know what are the functions that are there within ggplot2 package? When you go into this page, right, the package page, right, ggplot2, so here you can see that it says create data visualization, right, using grammar of graphics. So as you go into this package, you can see there would be a reference manual. Okay, so this is the reference manual. I can open, this is a PDF file. So for every package you will have this reference manual. Okay, so once we have opened this reference manual, here inside, right, you can find these functions, and you will find this list of functions. Okay, and you can see this. So our topics documented here, it will tell you all these functions or variables or different components of a function that are discussed. Okay, so these are the functions and the page number where these functions are discussed, okay, or different components are discussed. For example, if we are interested in this ggplot function, we just click on that page number. It will take us to that function, right, and it will also describe, right, what are the things you can do, right, this, what does this function do, what are the arguments, right, and then finally you will also get an example. Okay, so this is something that's very useful. It will tell you how to use this function, and we can try this out on your data, right. So here it's a function that's on one data set. It's a data set that's also stored in R. It's an present in R already, and here it's showing this example with this data set. Okay, so you can do this here. Okay, so you have these different functions, right, and then you can use on your own data. Okay, so this is how you can start with different functions and how to use these data sets. So we have now installed this one package, right. So we have learned how to install a package, R package, standard R package, and how to look into different functions that are available within that package. Then I'll also illustrate how you install a bioconductor package. Okay, so bioconductor package installation is slightly different, and again, but these are all documented very nicely and clearly. So here is, for example, we want to install, let's say, just as an example, this genome infodb package. Okay, so it tells you how to install this package in this bioconductor package in R. Okay, so you can see this function. So you can simply copy this. So in bioconductor we can install package using this BioC manager. Okay, so first we need to install BioC manager if it is not there. So I'm moving into R, and I'll just paste this function, the command that they given. So this bioconductor version 3.19, right, BIOC manager is now there, and we'll use the second command that's given, BIOC manager :install and the package name. Right? So there is a slight difference in how you install the install a bioconductor package. If you use the install.packages command for a bioconductor package, you will get an error. So you can try this a bit later on, and you'll see. Okay, so it's saying that there is something wrong, right? So there might be same as greater than current. Okay, so what it's saying is that this is already there. This package is already installed in here, so it will not install. Maybe we can try another package. The command is same. Let's try another bioconductor package. Okay, let's say dsec2, and let's see if it works. Okay, so yeah, so this package dsec2 is not there, so it will now install this dsec2 package as well as the dependencies, right? So these dependencies are other R packages that are required for proper functioning of this dsec2 package. Okay, so installing through this command line or console actually helps you resolve all these issues. If you want to install manually, you have to install these packages individually, and then you can install dsec2, right? So installing through the command line is much easier and simpler for all of us. Okay, so so this installation is going on, so I want to show you how you can actually find the functions in a bioconductor package, right? So here actually is very simple. Again, it's like you have a PDF file. You can open this PDF file, and here you have these functions that are built in along with examples, right? So here is a very detailed discussion on how these methods work, right, and what are the things you can do, and then with examples. Okay, so that's very useful for us. You can also, if you want, you can also look at some of the R scripts, right? For example, here is an R script that is given along with this documentation, and here again you can see the R scripts that have been applied with example data sets. Okay, so these examples are very useful, because then you can understand how you can need to organize your data to actually apply these functions. Okay, so I hope this part this completes our discussion on how to install packages and how we can use functions from these packages. Then what we will do is I will now illustrate you how to use some of these basic operations that we have discussed about. Okay, so this installation is done, right? So we'll use some of these packages. We'll also install some of other packages that we will apply to our own data sets, and I'll illustrate how to pick those functions, etc. When we use those packages. For now, we'll now go into use these basic operations, right, or basic operators on in R, right, and maybe we'll take very simple data sets. Okay, so first we'll start with this getWD setWD function. Okay, so getWD, right, will give you the current working directory, right, so where you are. Okay, so this will give you a path where you are right now, but maybe your data is not here, right? So you have a new directory where your data is, and you want to go inside that directory and you want to process data, right? So for that we need to use this setWD function. Okay, so setWD, we can, so again we need to give the path now within these double quotes. Okay, so for setWD, I know the paths, but in your case, in your system, the path might be different depending on where R is installed, etc. So setWD is, we want to go to a desktop, and I have created a folder. It's called data analysis in R, where I will illustrate all these hands-on, right, where we'll put all the data sets and we'll apply our functions and analysis, etc. And we'll also generate plots and save plots here. Okay, so I want to go inside that function, so I have given this path dot slash desktop slash data analysis in R, and I just press enter. Okay, so whatever I'm doing here, you can also do inside RStudio, right? So you will see RStudio will be a bit more informative, but here this is the simplest setup we are working with. Okay, so now we can check the current working directory again, right? Get WD, and this is where we are. We are in the right directory, and we can now apply our techniques to the data sets, right? Wherever our data sets is, right? Okay, so we have discussed the set WD, get WD, right? The other functions that I want to discuss are ls and rm functions. Okay, so ls actually tells us what are the variables that are defined in the environment, in the R environment. Okay, so in RStudio you get them by default on another side, right? You have another panel that will actually show you these variables. Okay, so let's look at this ls function. Okay, so before we apply the ls function, because there is no variable defined right now, let's say I'll define a variable, let's say variable, and here I will assign, right? So I'm assigning this a value, right? You can use this equal function, that's equal to 3, or you can use this function, right? Assignment operators that we talked about, and say this is variable. Okay, so we have now defined a variable. So let's see ls. Okay, so ls will tell us, okay, there is this variable that is defined, that is in the environment, present environment. Okay, rm will remove this variable from the environment, right? So rm will undefined, right? So this variable value will be gone. Okay, so you can, if we type now variable, you will get 3, the value 3, right? Because we have assigned this value to this variable. For rm, we'll use this variable name that we want to remove from the environment. So rm is remove, right? And now if I type variable, there is nothing, right? So it says error object variable not found, right? Because it has been removed from the environment. And if I now apply ls, you will see that 0, which means there is nothing in the environment. Okay, so this is something we have defined. Okay, so we have now understood the ls and rm functions. The next one, as I said, we have also discussed the assignment operators, right? I will briefly discuss the arithmetic operators now, right? These plus, minus, multiplication and division, and then the power and the modulus function and the integer division function. Okay, okay, so the simplest ones, right? So we can define a variable now, and we can assign values, let's say 2 plus 3, right? So that's the simplest one. Or we can say 2 into 3, right? And we can just type a, that will give us the value of a, right? So these are very simple things. I want to show you, let's say, the power function, right? Okay, so 2 to the power 3, right? So whenever we write these 2, this tilde 3, right, to the power 3, so this sign is to the power 3, right? So 2 to the power 3, right? We can also define another function, let's say b to the power, let's say 10 to the power 3, right? And this is the to the power function, right? So similarly, we can define anything we want to define, right? I'm taking very simple examples, but you can see, right, we can make this much more complex. In case of bigger data sets, we want to transform data sets, we can also do this. Okay, so I also wanted to demonstrate you the modulus functions, right? So let's say the one that we discussed, right? Oh, sorry, the assignment operator is not correct, right? So here the remainder, right? So the remainder is 1, and if we just add this extra sign, right, let's see what is the value of 2, right? This is integer division, so this is 2. Okay, so we now have seen these basic functions, and then we can describe some of these log functions or median functions. As I said, the max, mean, the median, and the mean and the SD, these functions will illustrate when you talk about big data sets, right? So when you work with big data sets, we'll talk about these functions. Okay, so let's look into, let's say, max function. I will define, let's say, before, right? So if I get this max function, it will tell me, okay, out of these 2, 3, 4, these numbers, 4 is the biggest number, right? So you can now imagine, right, you can have a big column of data and you just want to find the maximum value, you can use the max function, right? Similarly, mean function, right, we can have 3, 4 and you'll get 2. Okay, so when you define data structure, we'll see this a bit more. Okay, so the other functions, let's say if we want to look at mean, right, the average of these 2, 3 values, right, mean value, and then, sorry, this would be the sum. Okay, so yeah, so that should be the sum. So because I have written 3, okay. Okay, so maybe we'll see. So we have to actually, for mean, we have to define this as a data structure. So let's say we have, so we'll discuss the data structure, right? So now this is giving the right value, not just the mean 2, 3, 4. So we have to use this as a data structure, and then we can do the SD as well, right? This will calculate the standard deviation. Okay, so we have illustrated some of these functions. So the other one that is remaining is the round function, right? So I'll discuss just that, right? So what we can do is we can say, right, so we can take this number, right, 1.00345, and say we round up to 2 decimals, right? So that's why it's giving 1, right? So we can take this a bit more, right? Let's say take this example, and now it's giving 1.01, right? So this is kind of a round function, rounding of the decimals. And then finally we have these relational operators, right? So equal to, not equal to. This will come when we actually go into the programming part, right? So let's say I'll define two variables, and let's try this. So I have defined 2 variables, a equals to 3, b equals to 4, and I'm asking a equal to b, right? So this is the way of asking if a equals to b or not, right? So here it's the output is false, which means they are not equal, right? The other way, if we can use, right, if to check, right, whether a is not equal to b, right? In some cases we want to do that, and here you get true, right? So this exclamation mark equal to means not equal to b, and this is true, right? A is not equal to b. Okay, so this is how, like, we can apply to simple data sets, but their real power actually comes when we apply on big data sets, right? So we take a column value, etc. We can apply these also greater than or small less than signs, right? And say whether, ask like whether a is greater than b or whether a is less than b, right? Those kind of functions we can write, very simple ones, and it will tell us false or true, right? Whether this is false or whether this is true. So this is just to illustrate, right, how we can use these functions and what are the outputs of these functions. Okay. Okay, so with that, I think we have illustrated the functions. I just wanted to summarize. So in this class we have looked into how to install R and how to install R packages, and as well as bioconductor packages. We have looked into basic operations in R, and those include assignment, arithmetic, mathematical and relational operators. We just took very simple data to illustrate those, but of course when we take bigger data sets, their real power would be much clearer to us, right? The real output that we get. Okay, so with that I'll conclude. Thank you.